Welcome again to another OKD briefing on the newest and latest bits of initiatives that are taking place in the OKD working group. Today we're going to talk about the operator build pipeline using Tekton. If you don't know what OKD is, it's the community open source distribution of Kubernetes that powers Red Hat's OpenShift. And OKD Streams is an initiative within the OKD working group that we're doing in conjunction with Red Hat Engineering to build pipelines for building OKD. And this has been ongoing for the past, 4 months now, as we have 2 streams now, OKD using Fedora CoreOS or FCOS, and now we have a CentOS stream CoreOS that we're building OKD with and have our first MVP release of that build coming out this week. And part of the OpenShift and the OKD ecosystem relies heavily on operators. And so today we're going to talk about the operator build pipeline that we've created using Tekton. That's part of this OKD Streams initiative. And Luigi Zuccarelli and Sherine Khoury are both going to walk us through all of this. And so Luigi, take it away. Tell us a little bit more about OKD Streams, and we'll have Q&A at the end.
Okay, so by way of introduction, my name is Luigi, as Diane's pointed out. I'm working on the CFE team, and I'll just let Sherine introduce herself quickly as well.
Yeah, so I'm Sherine. I'm also with the Red Hat OpenShift team. I'm working on the customer-focused engineering team, so same team as Luigi.
Cool. Okay, so we're going to be introducing the operator build pipeline using Tekton. And as Diane pointed out, we have this notion of OKD streams, and she put it really well that not only do we build FHCOS as the underlying operating system, but we also now have SCOS, which is also coming out in the MVP. And so we've coined it as OKD streams. So it gives us the notion of building multiple pipelines to realize OKD and all the necessary operating system that supports it. And then Tekton and Tekton pipeline requirements. Tekton is a Kubernetes open source project for CI/CD pipeline builds. It's really container-based, extremely flexible, extremely easy to use, in my opinion. Maybe someone might not agree, but very easy to use. It's extremely flexible, as I've mentioned. As the great thing is there, and we have a lot of at the end of the slideshow, we'll have a lot of links for you to go have a look at. But the power of Tekton is the Tekton hub, where you've got a sort of plethora of tasks that you can use and implement out the box without even changing a line of code. But you can obviously customize and use it as needed. So just a brief architecture overview of what we're trying to sort of build here, and why we've used Tekton and what we're actually trying to do here. So on a high level, I've got an architecture diagram just to point out the different pieces that are used in the actual build pipeline. So we have our pipeline runs over here. I don't know if you can see this. Yeah. Over there is the pipeline runs. We have pipeline objects, and we have task objects. Well, the tasks really could be like something like git clone, build a Golang program, put it into a Docker, that type of thing. This is what we mentioned by tasks. And then the supporting infrastructure, we have here we have config maps. Config maps are sort of objects within OpenShift that store key value pairs, and there we store credentials used for pushing images. We use Canico, the container Google Tools container tool. It's really, really cool, powerful. It builds and pushes the images. And then obviously we have our PV, persistent volume, and persistent volume claims. And then obviously all the necessary RBAC for us to realize the all the different rule-based access controls, permissions for the tasks. So that's the actual architecture and overview. And what I wanted to highlight here is just the different objects that we're using within the operator pipeline tree. You'll have a look here at the top. There's environments, overlays, and CI/CD, and we make heavy use of customization. Customization is also an open source tool that really helps with deploying multiple objects or multiple manifests. So it is plugged in using the kubectl command line. So instead of saying, for example, kubectl apply -f, you can say kubectl apply -k, and it knows that it must use customization, and then customization will run through and deploy your full application. So yeah, that sort of gives you a high-level overview. What I do want to iterate here and sort of explain is that this is a POC. It is a sort of an MVP, as Diane mentioned in the beginning. So it's very naive and very opinionated at this point in time. There are a lot of caveats in here, but what we wanted to show and what we wanted to highlight is that we're able to build operators and then deploy them into the operator hub. So more about operators, OLM bundles, and operator hub. The operator really is a way of actually putting your SRE, your site reliable engineers' work into a programming language like Golang, where we can actually then take all the stateful assets, the order that we deploy something in, and actually deploy that programmatically. And then as well as looking at the desired state that we want the deployment to be in, and the operator will run in a reconcile loop and make sure that we have the desired state that we want. That's at a very high level. Again, there's lots of good information on that we'll point you to at the end of the slide that you can read up on operators. OLM is really the operator lifecycle manager, and that makes sure that the operator is that we're able to have a life cycle. In other words, if I bump the version of an operator, I need a way of seamlessly upgrading that operator, and we can do that via OLM and OLM bundles. And the OLM bundles we'll talk later about, and you'll see in the demo where we create the operator. The operator might have an agent that it needs, like we call it the operand, and so we'll need to bundle the operator, the operand, and then put it into a catalog, and then the catalog is what we talk about Operator Hub. And in Operator Hub, there are operators that you can't access because in OpenShift, these are subscription-based. So in the Red Hat Marketplace, for example, there could be Tekton and Argo CD or some really cool database, but you can't access it because it is subscription-based and it's in OpenShift. So we want to build these pipelines to allow sort of the community access to build operators and catalogs and push it into the community's operator hub so that we have these operators available for OKD. Well, that leads me on then to handing over to Sherine to do a live demo, I believe, Sherine.
Okay, so what I'm going to show you here is how to build an operator using the pipeline that we've built on a kind cluster. So to start off, what is kind? Kind is Kubernetes on Docker. So basically it's using Docker containers as nodes and building a Kubernetes cluster on top. You can find that actually on 6 Kubernetes IO. It's very, very easy to install and it's extremely lightweight. So it's very, very adapted to developing, basically. You can create a cluster by doing something like kind create cluster once you've installed it. I already have one, so get cluster. My cluster is right here. Doesn't want to detect my finger anymore. That's fine. Okay. And get cluster. Sorry. So we've got a cluster. As you can see, I'm using sudo here, and that's simply because I'm not using kind on Docker, but kind on Podman. So if you're interested in that, we can also send some links to tell you how to tweak that. Now, on top of kind, we've installed the Tekton controllers. So to install that, it's pretty simple. There's a Tekton dev and some really nice YAML file where you kubectl apply the thing and it installs it for you. So I've already done that. I can show you here. I have a namespace called Tekton Pipelines. And in here, we can see that we have all the services, pods, deployments, everything that is needed, including RBAC, all of that is already in there. So it's a one-liner, you get Tekton on kind running. So that's basically about what I need in order to get myself started up. I've just pulled the OKD operator pipeline repo, where the pipeline code lives right now. Also, we'll get the links afterwards. And what I'm going to do is simply apply. Well, first, before applying, I'm going to change my namespace to OKD team. This is also in the README. It tells you to use OKD team. And as Luigi said a bit earlier, we're using customize in order to be able to apply everything. So I'm going to apply here the customized environment. And what I get out of that is everything RBAC related that makes the Tekton pipeline work. I get the pipeline deployed as well as 3 tasks. So we've got 1 task to clone the repo from GitHub. And this is basically one of the tasks that exist on the Tekton hub. We didn't really create that. The 2 that we created are the container all and the bundle all. So now that we've applied this to our namespace, we can start the pipeline. So as you can see, there's a lot of parameters here, but it's pretty simple. So I'm telling it to start the pipeline dev all. This is the name of my pipeline. And then I'm giving it a set of parameters to tell it, here is the operator repository that I want to build. This is the name of the repo where I want to push my my operator once all of my Docker images are built and ready. This is the registry where I want to push the version of the operator, and I'm gonna use a volume claim based on the standard storage class that you get out of the box with kind. So this volume claim is really so that we can share files between tasks and between steps of the pipeline, so that we can, for example, get the advantage of caching and not have a long pipeline. So let's okay, so let's start our pipeline. Our pipeline is started. It's got this random name, and we can even use this line here to look at the logs, see what's happening. So here the pipeline is going to take around 5 minutes. So this is going to take a little bit of time, around 7 minutes, more or less. So it's going to start first by cloning the repositories, as you see here. And then it's going to go into another task where it's going to build the containers. So starting by a big Golang CI step, which is, by the way, we've made it not to fail the whole pipeline, because we know operator to operator the linting rules could change, and the quality standards are not the same. So next, unit tests, and then we go into building the operator. So while we wait probably for this to kind of finish off, I can show you a little bit inside the code. So this is what a Tekton task would look like. There's the series of parameters. It's basically exactly the same parameters that we passed earlier in the command line. Here we see what we've been doing with the PVCs, if you remember earlier. So this is where we load the PVCs into the task so that it uses the cache and the PKG folder from the PVC instead of rebuilding each and every time it's going to start a new step. So the yellow step, the Golang CI lint step that we saw earlier, is this verify step. So here you can see that it's taking an image that we've built, and it's using that container in order to run Golang CI. So two little things to say here. The Go Bundle Tools is a container that has basically Go, Golang CI, Operator Framework SDK. What else, Luigi? I don't remember, but all of the tools. Customize.
Other supporting tools, yeah.
All the tools that you might need to get that operator basically built and run, and be able to kind of push it. So going back to here, we see that our build step is done, and now what we're doing here is preparing the Docker container of the operator to be pushed to a registry. We're using Canico here, which is very, very practical because we don't need to use a Docker engine. It runs unkind, and it can build any container exactly like if we were using Podman or if we were using Docker. It does both the build and the push in the same step, basically. So here, as you can see, we've pushed the operator. You're free to basically add another step in here to build an agent if your operator is using an agent, or a kube-RBAC proxy, for example, if you're using a kube-RBAC proxy with your operator and you need to build that. And what happens next here is this second task starts. So the bundle all is where we start building the OLM artifacts, or the operator lifecycle management artifacts, that are needed so that we can use our operators from, for example, Operator Hub or a community hub, and install them on an OpenShift cluster, on OKD cluster, and start using them. So first thing, we're building a bundle. As you can see, we're using operator SDK things. So it's based on operator SDK, and so we call bundle validate. Once that is done, we can push that bundle to a registry. And next, we need to create an index and a catalog. So these might look like fancy words, but they're really related to the way OLM handles the bundles. So what OLM in the operator hub shows is operator catalogs, and catalogs contain either one operator, like what we're creating here. We're creating a catalog containing one index which contains one operator. But if you take, for example, the Red Hat catalog, it contains, for a release, for example, it contains all of the operators that this release has. So here, to make things simple and to allow you to use your operator really easily, we've created the catalog image for you and the index image for you. Based on that, you can use, for example, a subscription YAML on your OKD cluster, and you can very easily deploy your operator to the cluster from that catalog that you've built. So that's about it. As we said, it's pretty opinionated. Yes, sorry.
Yeah. So has it finished? Would you mind just doing a TKN describe the pipeline build that you've just made?
Yes. So here is our last run of the pipeline. So you can see basically that this time it even took a minute less than last time, which I'm guessing is a little bit thanks to the cache.
The caching is working nicely. So if you don't mind, just TKN PR describe the name, and it'll give you a nice fancy little. Yeah.
Sure. That's how it looks. It lists all of the tasks and the time that each task took. Should we look at the Quay.io to see what bundles what images, sorry, got pushed, maybe. So here is, hold on, I'm just gonna share this here and sorted by last modified. So here are all of the images that we've built. We've built the operator, we've built the bundle that basically describes the operator, it describes all the related images there is, it describes which channel it belongs to, what version, which RBAC it needs, which deployments it needs. All of that is in the bundle. It's really something that the operator framework SDK builds for you. Then we have an index which contains the operator bundle, and finally the catalog, which contains one or more indexes according to your use case. So that's about it. We're hoping that soon we're going to be able to run this on Operate First, right?
Yeah. We had previously it ran on Operate First, but we had some credential issues, so we couldn't unfortunately show it today. But we will be together with the SCOS build pipeline. We'll show both of them in the near future, in the next couple of days, really. Cool. I'll share the last bit just to show the guys the links, and can you see that?
Yes, looks great.
So great. So the GitHub is OKD project, and specifically OKD operator pipeline. So please download it, fork it, play with it. As Sherine showed you, it's really easy to build locally. And I think this is the power of what we wanted, is that you can build these pipelines locally. You don't need a heavy Kubernetes infrastructure or OpenShift infrastructure to build it. But having said that, it really works well on a heavy OpenShift OKD streams type of cluster, and will work well. So PRs are welcome. As I've mentioned, there is the SDK operator framework.io. There's some really good documentation. Have a look at operatefirst.cloud, and then obviously okd.io for information on our OKD and OKD streams. So that's it. We'll hand over to Diane.
Well, thank you very much for that. It's great to see the progress we're making. I know operators and getting operators to work with OKD and creating the catalogs has been one of the initiatives within the OKD working group that's been going on for a long time. So this is really amazing to see it in a pipeline. The other thing I think you mentioned slightly, but we are going to put these up on Tekton Hub for people to use. So right now they're in the OKD project repo. So go there, make comments, tweak them out. We know, I know these guys sound like and are now experts in this pipeline, but we know there are Tekton experts out there and gurus, and we'd love to have your feedback on this and see if we can't make them more efficient and effective, and as always, probably better documented than we do on our first passes. So if you have PRs or comments or any issues, you try running this and you have some feedback, something didn't work quite right, please let us know. These things should run on any Kubernetes cluster. So they're not totally specific to running on OpenShift or OKD, but if we put anything in there that is, we want to hear about it. So again, thank you, Sherine and Luigi, for taking the time today. And I'll add this to the playlist of OKD streams videos that are up on our YouTube channel, and we will be following this up with more in the not too distant future. So if you're interested in this stuff, please go to okd.io, come to one of the working group meetings. They happen bi-weekly. There's a community development one on the other week. And there's lots of things people can do to get involved. And we just would love to hear from you.